This is the key to topic 2, part 2. And notice that you have these rational equations that you want to solve. The interesting thing about these rational equations is that the denominators in most of these are not monomial factors. So this is a binomial, this is a binomial, this is a binomial, this is a binomial, and so on. Now you have in one of these a trinomial. But the point being that they're not all monomial factors. So in that case, you will have to factor the denominators if it can be factored. All right, now the other thing is in the directions it says this. The approach you must take in all of these is that you must multiply both sides by the least common denominator. And so you must clear the fractions first. All right, so if you don't do that, then you're not following directions and you won't get any points. So you must multiply both sides by the least common denominator first. Okay? All right, so let's look at number 1. So number 1, we have this rational equation. Now this is the easier kind because if you look at your denominators, this denominator is x minus 4, and I cannot factor that any further. Okay, so remember the GCF is 1 here. You can't do anything else to this. It's a binomial linear factor. Here, that denominator is 1, so it's a monomial. And here, this is the same as this. So again, I cannot factor x minus 4. So once you determine that, then you found the least common denominator. The least common denominator must include every factor in your denominators. So this denominator is x minus 4. I have to use it. This denominator is a 1. Well, 1 goes into all factors. This number is x minus 4. I have to use it. I already have it. So that's your least common denominator. Then we got to find the restrictions because remember we are dealing with rational equations. And in this rational equation you have variables in the denominator. So you got to ask yourself what's going to make this denominator 0? Because if that's 0, then this fraction here is undefined. And so that's an easy kind because if you look at this, 4 minus 4 is 0. So x cannot equal 4. And what some students will do is they'll actually go off to the side and they'll take each of these factors they see and they'll set it equal to 0 and they'll solve for x. So if you add 4 to both sides, you would x to be 4. So there's one of your restrictions. X cannot equal 4. Then you go to the next denominator. So this is 2 divided by 1. So this is a monomial factor 1. That's never going to be 0. So then you go to the next one. X minus 4, I already took care of it. X cannot equal 4. All right, now once you find your least common denominator, the next step, remember the directions, you must multiply both sides by the LCD to clear the fractions. And so now notice that when we do this, you see how I have 2 fractions on the left side, 2 terms on the left side. So let's go ahead and put that in parentheses. So 3x divided by x minus 4, subtract 2, and I got to multiply by x minus 4. Whatever I do to the left, I must do to the right. So I'm going to have to multiply the right-hand side by the least common denominator also. But I'm not going to put this in parentheses because it's just one fraction. So I'm just going to say x minus 4 times 6 divided by x minus 4. It just makes it a little bit easier to deal with. So I don't have parentheses there to make it look messy. But I do need parentheses here because both of these have to be multiplied by x minus 4. So hence that distributive property. And so I get x minus 4 times 3x divided by x minus 4 minus 2 times x minus 4. So go ahead and write it like this. Make it look like this. Put that coefficient 2 in front of x, in front of the LCD. Okay, equal. And then let's go ahead and rewrite this over. X minus 4 times 6 divided by x minus 4. So remember the whole point of multiplying both sides by the least common denominator is to get these denominators to be factors of 1. So I want this to be a 1. I want this to be a 1. Okay? And so you can do that if you are multiplying both sides by the least common denominator. And so now let's go ahead and reduce. So the x minus 4s divide out. You see I have factors of 1 now. So x minus 4 and x minus 4 is 1. X minus 4 and x minus 4 is 1. Here, remember, that was 2 divided by 1. So I already had a 1 there. So let's go to the next one. These divide out again. And so now what you have is this. You have 1 times 3x is 3x. And I'm just going to go ahead and rewrite this over. So remember, all I want to do at this point is just to reduce. Equal, and then 1 times 6 is 6. Now, at this point, let's go ahead and distribute it here. And you could have done it here, but I just wanted to do it. All I wanted to do is just to simplify these two parts here. Okay, so I get 3x. If I distribute the negative 2, I get minus 2x. A negative 2 times a negative 4 is a positive 8. So you got to be careful with these. Equals 6. Now notice I went from a rational equation to a linear equation. Notice this linear equation, I don't have any fractions any longer. So that was the intent. So now it makes things a lot easier to deal with. Okay, so in this linear equation, notice that I can combine like terms on the left side. So 3x minus 2x is x. I got x plus 8 equals 6. And then to get x by itself, let's go ahead and subtract 8 from both sides. And then combine like terms, that's 0, 8, and negative 8, 0. So I get x plus 0 is x equal 6 minus 8 is a negative 2. All right, now, before you say that's your solution, remember, x equal negative 2 is a solution to this linear equation, but it may not be a solution to the rational. That's where you got to look at your restrictions. So is x equal negative 2 this restriction? No. So that means that if I were to substitute x equal negative 2 into the variable x, the left side will equal the right side. Okay, so that's your solution, x equal negative 2. Okay, let's look at the second one, number 2. Okay, so number 2 is very similar to number 1. Again, notice the denominators are not, this is not a monomial factor. This is not a monomial factor. This is 4 divided by 1, so 1's a monomial factor. But since this is a binomial, remember you want to try and factor it if you can. So x plus 12, if you notice that the GCF of both terms is 1, so there's nothing to factor here. So that means that the least common denominator must include every factor you see. So the first thing you have to do is to factor, and I cannot factor anything in the denominators. So let's rewrite the LCD using those factors. So x plus 12 occurs as a factor here. I have to use it. Over here, that's 4 divided by 1. 1's a factor of everything. And then over here, x plus 12, I already have it. So there's your least common denominator. Now let's find the restriction. So once you factor, then, and in this case, you remember we couldn't factor anything, but so to find a restriction, I take each of these factors and I ask myself, what's going to make x plus 12 equal to 0? That's what you're asking yourself. So to solve this, and notice this is linear right here, I'm going to subtract 12 from both sides, and so I get x to be negative 12. And so negative 12, if you think about it, makes this 0, because negative 12 plus 12 is 0. So there's your restriction. X cannot equal negative 12. In this denominator, that's a 1, so that's never going to be 0. There's no variable. You don't see a variable here. Over here, we already did that. Negative 12 plus 12 is 0. So there's only one restriction in number 2. Okay, now once you find these, let's go ahead and multiply both sides by the least common denominator to clear those fractions. You want these denominators to be factors of 1s. So notice that the left-hand side, there are two terms here, two fractions. Let's put them in parentheses. 1 divided by x plus 12, that's a 12 here, minus 4. And we're going to multiply by x plus 12, equal, and the same thing here. Now notice that since that's just one fraction, let's go ahead and don't put that in parentheses. So 3x minus 40 divided by x plus 12. Okay, now the next step is to go ahead and distribute. And so I get x plus 12 times the first rational expression minus 4 times x plus 12. Equal, and let's go ahead and rewrite this over. X plus 12 times 3x minus 40 divided by x plus 12. Okay, now at this point, remember the whole idea, the whole reason for multiplying both sides by the least common denominator is that at this point here, these should now be factors of 1s. And it is, because x plus 12 will divide to x plus 12. So x plus 12 and x plus 12 is 1. Same thing here. X plus 12 and x plus 12 is 1. X plus 12 and x plus 12 is 1. Okay? Now, let's go ahead and rewrite this. So 1 times 1 is 1. I'm just going to rewrite this over. Minus 4 times x plus 12 equal 1 times 3x minus 40 is 3x minus 40. Okay, now at this point, let's go ahead and distribute. Make sure you distribute before you subtract. Don't say 1 minus 4 is a negative 3 and distribute negative 3. That's mathematically not correct. You have to multiply first, so hence distributing, and then subtract. So I get 1, a negative 4 times x is a negative 4x, a negative 4 times a positive 12 is a negative 48, equal 3x minus 40. Combining like terms, I get negative 4x, and then 1 and a negative 48 is a negative 47, equal 3x minus 40. And then let's go ahead and remember now this is linear, so this is a linear equation. And so I went from a rational equation to a linear equation. So let's solve this linear equation. So now it's an easier thing to deal with. You don't have any fractions to deal with any longer. And so let's go ahead and bring the variables to the left, constants to the right. So I'm going to subtract 3x on both sides. And let's combine like terms. So a negative 4x and a negative 3x is a negative 7x minus 47 equal, and then the 3x minus 3x is 0, and 0 and negative 4 is a negative 40. All right, so right now I'm subtracting 47. The opposite is to add 47. And so I get negative, this is 0 when I combine like terms. So negative 7x and 0 is negative 7x equal a negative 40 and a positive 47 is a positive 7. And divide both sides by negative 7. And then reduce. Negative 7 divided by negative 7 is 1. 1 times x is x. I get x to be, negative 7 right here. So 7 divided by negative 7 is a negative 1. So there's your solution. Now, before we go there, we got to be careful. Negative 1 is a solution to this linear equation, but is it a solution to the original, to the rational equation? Just check your restriction. Is negative 1 a restriction? No. So if you were to actually substitute negative 1 in for x, you'll see the left side does equal the right side. And so there's your solution for number 2. Okay, let's look at number 3. Okay, so in number 3 we have this rational equation. Now we're at a situation where when I look at those denominators, x minus 2 I cannot factor any further, x plus 2 I cannot factor any further, but you have to remember that this is the difference of two squares. And so I can factor x squared minus 4, and when I factor x squared minus 4 I get x minus 2 times x plus 2, and that's how you're going to write this. So you're going to write these in factored form. Okay, so that's your first step, is to write in factored form. Okay, now let's find the least common denominator. So your least common denominator must include every factor that you see. I see an x minus 2, I have to use it. I see an x plus 2, I have to use it. Now I'm going to go back, since if you go back to numbers 1 and 2, you'll notice that in number 1, that was just one binomial year LCD. And the same thing here in number 2. So notice I didn't use parentheses at all. But over here, since my least common denominator is going to involve more than one factor, we have to put that in parentheses. So x minus 2, x plus 2. Okay, now let's go to the next set. So x minus 2 is a factor, I have to use it. I already have it. X plus 2 is a factor, I have to use it. I already have it. So there's your least common denominator. Now, once you find the least common denominator, you find your restrictions. And basically, all you do is look at your factors. What makes this? Look at the factors that are in your denominators. So remember, when find the restrictions of rational equations, you're trying to find out what makes this fraction undefined. Well, this fraction is defined when the denominator is 0. Same thing here. That fraction is defined when the denominator is 0. This fraction is undefined when the denominator is 0. So if you look at this, x minus 2, and I set that equal to 0, I want to find out what makes this x minus 2 equal to 0. So you add 2 to both sides, and now you have x is 2. So 2 makes this denominator 0, because 2 minus 2 is 0. So there's one of your restrictions. X cannot equal 2. But there's more than one now. So numbers 1 and 2, there was only one restriction. See, there was only one restriction because you only had one factor. You had one restriction here because you only had one factor. as your least common denominator. Here, there are two factors. So you're going to have two restrictions. Well, let me rephrase that. You have two factors that have variables in it. So you're going to have two restrictions. And those factors are different. Okay, so what makes this denominator 0? So x plus 2 equals 0. Subtract 2 from both sides, you get x to be negative 2. So there's your other restriction. And then notice I don't have anything to do here because these I already took care of. That's this right here. So those are your restrictions. So notice that this is this right here, right? And so all you do is find out what makes this 0, what makes this 0. Okay? Now, once you find your least common denominator, you're going to multiply both sides by the LCD. All right, now, so notice that on the left side, there are two fractions. So let's go ahead and put that in parentheses. And then you're going to say times the least common denominator. So you're going to say x minus 2 times x plus 2 times the left side. 1 over x minus 2 plus 1 over x plus 2 equal. And then notice that since this is just one fraction, let's go ahead and just not use parentheses, but you need to use the factored form. So you're going to say the LCD times negative 3 over x minus 2 times x plus 2. And the reason you want to do that is because these factors are these. So you can easily see, so instead of saying x squared minus 4, write it in factored form. So that way you'll see soon that you can reduce these very easily. Okay, now we got to distribute. We got to get rid of these brackets. So I have x minus 2 times x plus 2 times the first rational expression plus the LCD times the second. X minus 2, x plus 2 times 1 divided by x plus 2 equal, and let's go ahead and rewrite this over. X minus 2, x plus 2 times negative 3 divided by x minus 2 times x plus 2. All right, now just like we've been doing, the whole point of multiplying both sides, the whole point of multiplying every term by the least common denominator, you see that this is being multiplied by the least common denominator, this is being multiplied by the least common denominator, and this is being multiplied by the least common denominator. The whole point of multiplying by the least common denominator to get these is to clear the fractions, so to get these factors to be 1s. So x minus 2 into x minus 2. So that has to reduce with one of these factors in your LCD, and it does. This has to reduce with one of these, and it does. And both of these reduces with each other. Okay, so now what we have is this. We have 1 times x plus 2 times 1, and that's just x plus 2. Plus x minus 2 times 1 is x minus 2 equal 1 times negative 3 is negative 3. Okay? All right, so that's where we're at. Now, the next step is to combine like terms. And so when I combine like terms, I have x plus x is 2x. 2 and a negative 2 is 0. So that's just 2x here equal negative 3. And then divide both sides by 2. I get 2 divided by 2 is 1. 1 times x is x. I get x to be negative 3 halves, or if you want to, you can write as a mixed number, negative 1 and 1 half. Now, this is a solution to the linear, but is it a solution to the rational equation? And so all you got to do is just check your restrictions. Is negative 1 and 1 half a restriction? No. So if you were to actually take this number, negative 1 and 1 half, and substitute it into x, where we see an x, the left side will equal the right side. So there's your solution. All right, so that was number 3. Okay, so let's look at number 4. Okay, so number 4, we have 7 divided by 2x plus 9 divided by 2x plus 16, and then equal 4 divided by x plus 8. So in solving a rational equation, the first thing you have to do is factor the denominators. Notice that these are monomial factors, so there's nothing to factor here. Here, this binomial, remember you got to remember your factoring from previous course. Here I can factor out a 2. So you got to do that. You got to say 2 times x plus 8 You can factor out a 2. The GCF of these two terms is 2. And you can always check yourself. 2 times x is 2x, 2 times 8 is 16. So that's the first thing you have to do. It's got to look like this. You have to say 2 times x plus 8. Over here, this is a binomial and the GCF is 1. And so so the first thing I did was to factor, and I factored the denominators, and the only thing I could have factored was this one. The next thing you got to do is now find the least common denominator. So your least common denominator must include every factor that you see. Every factor that you see. So if I look at the first denominator, there are two factors here. A factor of 2 and a factor of x. Okay? So I have to have 2x in my least common denominator. The next one, if I look at the next denominator, I have two factors as well, 2 and x plus 8. Well, I already have a 2. 2 goes into 2, but I don't have x plus 8, so I got to have x plus 8 as a factor. Then my next denominator is x plus 8. I already have it, so there's my least common denominator. So your least common denominator involves three factors, 2, x, and x plus 8. So there's your least common denominator. Now let's find the restriction. Okay, so to find the restriction, you got to look at each factor in the denominator. So what makes this denominator 0? Well, 2 times what is 0? Well, 2 times 0 is 0. So x cannot equal 0. Over here, what makes this denominator 0? So all you got to do is look at the factor that has a variable in it. So x plus 8. So ask yourself, where's x plus 8 equal to 0? Well, if I subtract 8, I get x to be negative 8. So negative 8 plus 8 is 0, and 0 times 2 is 0. So that makes my denominator 0. And these two are the same, so the restriction for this is this as well. So there are only two restrictions, 0 and negative 8. All right, now, once you find your least common denominator, let's go ahead and multiply both sides by the least common denominator. Notice that there are two fractions on this side, so let's put that in parentheses. There's only one here, so I'm not going to use parentheses on this side. So I get 2x times x plus 8. So remember, you're multiplying both sides by the least common denominator. Times 7 divided by 2x plus 9 divided by 2x plus, let's go ahead and use factored form. Factored form, don't forget factored form. So 2x times x plus 8. Equal, and then 2x times x plus 8 times 4 divided by x plus 8. So don't forget, you got to use a factored form here. And the reason we want to use a factored form is so that way you can see which factors divide into LCD. So once you do that, then the next step is to distribute. So I get 2x times x plus 8 times 7 divided by 2x, that's multiplication here, plus, and then the LCD times the second fraction, the second rational expression, 2x times x plus 8 times 9 divided by 2x times x plus 8. Now remember a while ago I said make sure you use the factored part because now you can see that the 2's divide out, the x's divide out, and the x plus 8's divide out. And then equal, and let's go ahead and rewrite this over, 2x times x plus 8 times 4 divided by x plus 8. Okay? All right, at that point, let's go ahead and reduce. So remember the whole point of multiplying both sides, multiplying every rational expression by the LCD is to get these, is to clear your fractions, to get these denominators to be all factors of 1s. And now you can see that. 2 into 2 is 1. See, these divide out now. X and x is 1, x and x is 1. Okay, over here. Now notice that 2 into 2 is 1, x and x is 1, so those divide out, and then the x plus 8's divide out as well. And over here, the only thing I can reduce is the x plus 8's, just like this. Now be careful on this side. This is 1, see 1 times 1, right? So 1 times 1 is 1. Now remember, multiplication is commutative. You have 1 times x plus 8 times 7. See that? So multiplication is commutative, meaning that the order in which you multiply does not matter. So listen to what I'm doing. 1 times 1 is 1. 1 times 7 is 7. So I'm putting the 7 in front. The 7 times x plus 8. So that is this. Plus, and then be careful here. That's 1 times 1 times 1 is 1. and then this is 9, and so 1 times 9 is 9, equal. Over here, I have 2 times x times 1 times 4. Again, multiplication is commutative, so listen to what I'm doing. 2 times 1 is 2. 2 times 1 is 2. 2 times 4 is 8. So this becomes 8x. All right. And now notice I still have parentheses here, so let's distribute. So I get 7x plus, and then 7 times 8. 7 times 8 is 56. So I get 7x plus 56 plus 9 equal 8x. And then combining like terms, I get 7x plus, and then 56 plus 9 is, what's that, 65 equal 8x. And then notice I have a linear equation. So I went from a rational equation to a nice linear equation now. And so now I'm going to subtract 7x from both sides. Okay, so I just realized something. I did have an error here. You see where I have this right here is 2 times x plus 8? All right, so be careful. I did, for some reason, I put an x here. It's just, this should be just 2 times x plus 8, okay? So I got to fix some stuff here. So that's going to be 2 times x plus 8, all right? And then all I got to do now is this. So you see where I had made a mistake. I put an x here and divided these x's, so that x is still there, okay? So the x is still here. So this 2 divides out with this 2, and this x plus 8 divides out with this x plus 8. So what I'm saying is that this right here, so 1 times x, that's an x now, times 1 times 9. So 1 times x is x times 1 is x, and x times 9 is 9x. So this needs to be a 9x. So that needs to be a 9x, so that's going to change this. Okay? All right, so be careful. You can easily mess up just like I just did. So be careful. All right, now let's go ahead and combine like terms. So I'm going to get 9x plus 7x is what's that, 16x? Plus 56 equal 8x. And then let's go ahead and subtract 16x from both sides. So I'm going to subtract 16x from both sides. And then that's 0, so I get 56 equal. And then 8x minus 16x is negative 8x. And then divide both sides by negative 8. I get negative 8 divided by negative 8 is 1. 1 times x is x. I get x to be, and that's 56 divided by negative 8 is negative 7. And then notice, though, that negative 7 is not a restriction. So assuming you did all this work correct, and remember, I almost ended up the problem not realizing that I did make an error. So there's my error here. It happens. Okay, so be careful. And so there's your solution. All right. So that's number 4. Okay, so let's look at number 5. So number 5, we have this in number 5. Okay, so this is number 5. So again, I want to solve this rational equation. So to solve this rational equation, you're going to find the LCD first. And to find the LCD, you got to make sure that all of your denominators are in factored form. So x plus 4, I cannot do anything else to it. So it's already in factored form. This same thing, it's already in factored form. But here I have this trinomial. I can factor the trinomial x squared plus 7x plus 12 as the two binomials x plus 4 times x plus 3. All right, so x plus 4 times x plus 3. And notice that these factors are the same as these, so it's going to make this a lot easier to deal with. Okay, now let's go ahead and find the LCD. So your LCD must include every factor that you see. I see an x plus 4, I have to use it. I see an x plus 3, I have to use it. Now let's go to the next one. I see an x plus 4, I have to use it. I already have it. I see an x plus 3, I already have it. So there's your LCD. So your least common denominator involves two factors, x plus 4 times x plus 3. Okay? Now once you find your least common denominator, let's go ahead and find the restrictions. So you're asking yourself, what makes this denominator 0 when you find the restrictions? So x plus 4 is equal to 0. So that makes x plus 4 equal to 0. So let's go ahead and subtract 4. And so I get x to be negative 4. So there's one of your restrictions. X cannot equal negative 4. The next one, x plus 3, same thing. What makes that 0? Well, if I subtract 3 from both sides, x equals negative 3. So there's the other restriction. So negative 4 and negative 3. It kind of makes sense because if you look at this, negative 4 plus 4 is 0. Negative 3 plus 3 is 0. And over here, you remember you got to look at all your denominators. Over here, that's already taken care of. What makes this 0? When x is negative 4. What makes this factor 0? When x is negative 3. So there's only two restrictions. And notice the restrictions correspond to the factors in your LCD. See that? So that makes this negative 4 makes this factor 0. Negative 3 makes this factor 0. Okay, once you find your least common denominator, the next step is to multiply both sides by the least common denominator. So I'm going to go ahead and kind of bring it down here. So I get 4 divided by x plus 4 plus 5 divided by x plus 3. And you're going to multiply that by your least common denominator. X plus 4 times x plus 3. Same thing on this side. So now remember, when you write this side, make sure you put the factored form. So you get x plus 4 times x plus 3 times 5 divided by x plus 4 times x plus 3. Okay? So now, remember the first thing you have to do is multiply both sides by the least common denominator, and I did. Now notice I have parentheses or brackets here, so you got to distribute to get rid of those parentheses or brackets, whichever one you used. So you're going to say x plus 4 times x plus 3 times the first rational expression, plus, and then the LCD times this, x plus 4 times x plus 3 times 5 divided by x plus 3, equal, and this is going to rewrite this over. I may not have enough room, so I'm going to write smaller, x plus 4, x plus 3 times 5 divided by x plus 4 times x plus 3. All right, now at this point, if you did this correctly, at this point, remember the whole point of multiplying by the LCD is to clear those fractions. So at this point, these should now be factors of 1s, and it is, because notice that x plus 4, you have a factor here in the LCD, so those divide out. Make sure you put factors of 1s in their place. Same thing here, the x plus 3's divide out. And then here, x plus 4's divide out, x plus 3's divide out. And what we have now is this, 1 times 4 is 4, so that's going to be multiplied by x plus 3. So 4 times x plus 3. Plus, and then x plus 4 times 1 times 5 becomes 5 times x plus 4. Equal, and then 1 times 5, that's just 5. Okay, now let's go ahead and distribute here now. So I get 4 times x is 4x, 4 times 3 is 12, plus 5x, and then 5 times 4 is 20, equal 5. Combining like terms, again, notice I have a linear equation. You see that? So I went from a rational equation to a linear equation. And so let's combine like terms. 4x plus 5x is 9x. 12 and 20 is 32, equal 5. Subtracting 32 from both sides. Combining like terms, I get 9x equal a negative 27. Divide both sides by 9 to get x by itself. So 1 times x is x, and I get negative 27 divided by 9 is negative 3. All right, now negative 3 is a solution to this linear equation. All these linear equations here. But the question becomes, is negative 3 a solution to the rational equation? And the answer is no, because negative 3 is a restriction. So you see, negative 3 makes this denominator 0. So 5 divided by 0 is undefined. So negative 3 cannot be a solution to the original equation. So what that means then is that this is a restriction, right? That's a restriction, so therefore you're going to say no solution. No solution. Okay? All right, so that is the key to the worksheet on topic 2, part 2. That's the one where we had to solve rational equations.